Well, here we are supposed to prove that the derivative of tangent inverse is equal to 1 over x squared. And you may be thinking to yourself, why am I proving a derivative in a section that is about integrals? Well, the skills needed for this are also needed in the section that's coming up, so it's a good idea to practice these. So first of all, the tangent inverse of x. If someone took tangent inverse of something, then what they're going to get out as an answer is an angle. That's the whole job of the inverse trig functions. You plug in some number here, they'll tell you, alright, that comes from two sides of a triangle, namely opposite and adjacent, and the angle across from that opposite is theta. So if you now take tangent of both sides, we would have that tangent of theta is equal to x. And we can even draw a right triangle. Tangent is opposite over adjacent if this is the theta. And somebody divided those two sides and they got the answer x. So that must be that it's opposite over adjacent is x over 1. Now if you do the Pythagorean theorem to solve for the hypotenuse, you will find out it's the square root of 1 plus x squared. So you'd square these two sides, add them together, that equals this side squared, and then to solve for that side, take the square root. Good. Now what about derivatives? So over here we could take the derivative of both sides. We would have the derivative of tangent is secant squared theta, and then according to the chain rule you need to take the derivative of this. Right now we're taking the derivative with respect to x since that's what the directions say, so it's going to say d theta dx, and the derivative of x is a 1. Well, notice d theta dx, that's saying the derivative of theta, since theta is equal to tangent inverse, that's saying the derivative of tangent inverse. So in other words, we need to solve for this. So divide both sides. It's going to be 1 over secant squared. Since 1 over secant is cosine, this is really cosine squared. So the left-hand side is saying take the derivative of tangent inverse, and you get cosine squared. But the question was in terms of x, so our answer needs to be in terms of x. Go back over to this triangle and find out how much is cosine of theta. Well, cosine is equal to adjacent over hypotenuse, so that's going to be adjacent over hypotenuse. That means that if you square both sides, or square both sides of this, it's going to be 1 squared on the top and the radical will be gone. So it's 1 over 1 plus x squared is the derivative of tangent inverse.